Let's continue. In the last class, we have studied about character sets, that is, identifiers, reserved words or keywords, and rules for naming identifiers, literals, constants, types of constants, escape sequence characters, and punctuators, string constants, about various things we studied. Let's continue the chapter with C++ operators. An operator is a symbol that tells the compiler to perform specific mathematical or logical manipulation. So we say operator is a symbol to perform some particular operations. See, for example, if I'm writing A plus B in this, A then B are called as what? Operands. In the above equation, A and B are called as operands. Plus sign is called as what? Operator. So without operands, without these operators, equation or expression cannot be constructed. So both of them are very important in preparing expressions. So C++ provides you rich set of built-in operators. There are almost 45 different operators. These operators can be either unary, binary, or ternary operators. So an operator is a symbol that represents an operation to the compiler. So here they have given different operators and their description also. There is a separate chapter for operators. There we are going to have a detailed discussion on it. So here, now category wise, we'll see unary operator in the sense. So in this, you saw that like in A plus B, plus sign takes two operands. So we have three categories of operators based on how many operands will be taken by every operator. Based on this concept, operators have been categorized into three categories: unary operator, binary operator, ternary operator. So unary operators are those which takes only one operand, only one operand. They are evaluated before any other operations containing them gets evaluated. See, they are evaluated before any other operations containing them gets evaluated. That means, say you are writing -5. This is unary operator because minus sign, if we write one number, it's enough, it will work, right, to represent the negative number. Even plus is also what? Unary operator because it works even on single value also. Whereas division operator, we can't say this as a unary operator because we can't write division operator by using only one operand. You need to have two operands. See, you can't write only 7 divided by, or you can't write only divided by 8, right? You need to write 7 divided by. Both numerator and denominators, both are required. That's why these are not unary operator. Minus and plus are generally used unary operator, but along with that, there are some other unary operators and they are here. Logical not operator and address of operator is there, and even reference operator also in C++. And this is one's complement, converts 1 to 0, 0 to 1. And this is also called as a tilde operator, tilde. We call it as a tilde. In the keyboard, in the numbers category, before the number 1, that tilde operator is there. If you press shift and that key, which is above the tab key, you will get this option. And the star asterisk, it is called as, it is used for pointer dereference, and even it is used for multiplication sign also. Plus, unary plus, not binary plus. Increment operator is there. Minus is there. Unary negation and decrement operator is there. About all these things, as I said, there is a separate chapter. One moment for your confirmation. I'll show you the contents so that there we can have a detailed discussion on it. Right now we are in this one. Here only they have given those statements. So no, they have not given a separate chapter. They have given it here only. We have to discuss here only in detail. There is no separate chapter for operators. So now here, in this we have plus plus and minus minus special operator, unary operators. Let's have a little more discussion on this. The plus plus is called as unary increment operator. Minus minus is called as unary decrement operator, where plus plus is used for increasing the value of the variable by 1 and minus minus is used to decrease the value of the variable by 1. Let's see practically how it is going to work. Suppose if there is a variable called as a having a value 10, right? Where in this, if I want to increase the value of a by 1, mathematics usually we write a plus 1, where for the present value of a, we add 1. The present value of a is 10 plus 1 is, at this stage, a is 11, right? The same equation can be written as a plus plus, right? A plus plus. In one more way also we can write, that I'll show you later. And now here, same way, if say b is having a value 10, if I want to decrease the value of b by 1, we write b equal to b minus 1. This can also be written as b minus minus. B minus minus. So that b minus minus is what? It decreases the value of the variable by 1. Now here we have, along with this, we have some more things. Pre-increment operator. Pre-increment means that plus plus sign we write before the variable. Suppose if I say post increment, not decrement, we write plus plus sign after the variable. The same thing is there even for decrement, minus minus a. As minus minus sign we have written before the variable name, it is pre-decrement. And this is post decrement, a minus minus, where minus sign, minus minus decrement operator is written after the variable name, so it is post decrement. When you are writing them individually, this pre or a post, that doesn't make that much no effect. There will be just increment and decrement operator. But when you are using this pre and post increment and decrement operators as a part of some equation, then so these operators, the incrementing decrementing action will be done in different timing. That means different period of time. So let's see how it will work. Say there is a variable called a having a value 10, b having a value 20. So now in this I'll write c equal to a plus b. Then plus, one space I'll give, plus plus a I'm writing. That means what? As plus plus is written before the operator, Then what kind of increment it is? Pre-increment. Suppose if I write minus minus b, it is pre-decrement. If I write plus plus after the variable name, it is post-increment. And see, b minus minus I'm writing after the variable name, so it is post-decrement. So let us solve this equation, how it will work. Let's substitute the values into this equation. A, as per above value, A is 10. And plus B means 20. Plus, excuse me, plus A stands for increment, pre-increment operator. See, pre means what? Before. Post means afterwards. See, your course name, PUC, stands for what? Pre-university. Right. PU stands for pre-university. That means PUC is such a course which has to be done before you start learning anything in the university. That means if you want to learn if you want to take some education from the university, you have to learn first PUC, pre-university, before university. The same concept will adopt here. Before I substitute the value of A into the equation, first you have to increase, as it is pre-increment, increase the value of variable by 1 first. That is 10 will become 11. It is not division. It was 10 because of plus A here, pre-increment. The value of A, which was having 10, got incremented by 1. So now it is 11. So after incrementing, that incremented value has to be substituted here. That means in the pre-increment or in the pre-decrement, first you increase or decrease the present value of the variable and then substitute that new updated value, incremented or decremented value into the equation. Kindly note this point. After that, minus B, pre-decrement. First, the 20 has to be decreased by 1. 20 minus 1 is 19. That 19 should be written here. And A plus means post increment. Post increment means what? Post means what? Afterwards. See, you know, when the students do MSc, MA, MBA, right? MCom, these are all PG courses. PG stands for postgraduate. That means graduate courses are what? BA, BCom, BSc, these are graduate. Postgraduate, these are the courses which have to be done after the graduation. That is why post, after graduation. In the same way here, post increment means first substitute the present value of variable A into the equation and then increment it. What is the present value of A? 11. That you substitute here first. And then after substituting the present value of A, 11, now you increment it. Now where I should use this incremented value? Next, when the next occurrence of A comes in this equation, that time you can use. Okay. And now plus B minus post decrement. First substitute the present value 19 into the equation and then decrease it by 1. So if there are any other occurrences of A and B further in this equation, then you can substitute. Otherwise, you calculate this entire result, that will become the value of C, and the final value of A was, after this equation, 12 and B was 18. This is how this increment and decrement operator will work. So recheck this part once again for to have a perfect concept based on this. So unary operators operate on single operand. See, identify. So here they have given same equation, same kind of equation. That procedure they have given, already I have explained. You just go through it and try it. Binary operators are those which requires two operands. Binary stands for two, because binary's base is how much? 2, because there are 2 digits. Binary operator says it requires 2 operands. There are arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators. These all operators are there, types of operators. Arithmetic operators like plus, minus, multiplication, division. See, in the general mathematics, what division operator you write, that is not there. You have to use this slash only. And this percentage sign is very special. This is called as modulus operator, which is used to get the remainder of the division. For example, if I say 7 divided by 2, result will be 3.5. Quotient of the division you will get. Suppose if I say 7 modulus 2, you will get remainder of the division. 2 3 are 6, 7 minus 6 is 1. That 1 is the remainder that you get. This is the difference between division operator and modulus division operator. And modulus division operator or modulus operator, this is very much helpful operator, the further part of the programming. So kindly remember the concept correctly. And relational operators are used for comparisons. If the comparison is the comparisons between two operands for greater, lesser, equality. Based on that comparison, it will return either true or false, which is called as Boolean value. So in programming, especially in C and C++, this is 2 equal to sign, we call it as is equal to. See, if you are writing like this, don't say A equal to 10. It is wrong. Single equal to sign in C++, it is not called as equal to. Here, when this is, that word you have to use only during comparisons. See, A is equal to B. There above you can see A is 5 and B is 10. So A is equal to B. It is false because both the values are not equal. Once again, in the mathematics, not equal to symbol is different. All of you know very well. But in programming C++, we have this operator. E is not equal to. A is not equal to B. True. Yes, A is not equal to B. And this is greater than, same as mathematics. Lesser than, greater than or equal to is different from mathematics. And lesser than or equal to, this is also different from mathematics. Kindly note. So they'll return either true or false. These are what? Relational operators. And logical operators are, these are used to join more than one relational expression. This is logical AND, logical OR, and this is logical NOT. Like in English, you learn about conjunction words, no? And, or, like that. Here, these are logical operators for combining more than one relational expressions. Which expression, which equation do you call it as relational expression? An expression which uses a relational operator is called as a relational expression. Logical operators are used to join more than one relational expression. The A greater than B and A greater than C, where A greater than C and A greater than B both are relational expression, both are clubbed by using logical operator. So here, this is a logical expression because this expression is created by using logical operator. So it is called as a logical expression. Which operator is involved in creating that expression? No, that expression will be named by that operator name. And then this AND, logical AND is what? So you can give any number of conditions, no restrictions on that. You can say A greater than B. Any number of conditions you can have. So what will be the final output of this equation? The final output, if all the given conditions are true, right? If all the given conditions are true, final result is true. If any one condition in this, if it is false, any condition, if it is false, even though all other are true, it is false only. And if all the conditions are false, that time also it is going to be false. That means you will get true only when all the conditions are true. In all other situation, it is going to be false. The same if I write using OR operator, two vertical lines. If any one condition is true, whatever may be the status of other conditions, right? The final answer is true. That means it is going to be false only when all its conditions are false. Otherwise, in all other cases, it is going to be true only. Assume that if I write not here, what result we were getting with this selected expression? No, you are going to get its opposite answer. If the selected expression gives you true, not true means you'll get false. If the selected expression is giving false, the answer with the not is what? True. You'll get opposite, negation result. We have bitwise operators. These operators works on bits and performs bit by bit operations. The truth table for bitwise operations for AND, bitwise OR, bitwise XOR are as follows. These are the input values. These will work only for binary digit. As 0, 0 is there, A, bitwise AND B. See, both logical, that reference operator or address of operator is also like AND only. Many operators plays multiple roles in C++. They are not intended for one work. A and B, 0 and 0 gives you 0 only. Whereas A bitwise OR also gives you 0. A XOR B gives you 0. Here first operand is 0, second is 1. This first one is 0. A bitwise OR B means 1. A XOR B means 1. When both are 1, AND and OR, bitwise AND and OR gives you 1. XOR gives you 0. When first one is 1, second one is 0. First one is 0, second one is 1, then XOR will be 1. Let us see with the example. Assume that if A is equal to 60 and B is equal to 30. First, you have to convert these number to its equivalent binary format. Here the conversion is done. In the previous chapters, we have discussed how to convert decimal number to binary. After that, perform bitwise AND operation or operation, not operation on it. A and B gives you this, that is 12. Similarly, A or B gives you this operator. See, it is based on this truth table only. So you can see here 0, 0. First A 0, B 0, 0. Second one is also 0. Third one, 1, 0 is there. This you see, 1, 0 gives you 0. That is why third one is also 0. Once again, 1, 0 is there, 0 only. 1, 1 is there. Here, 1, 1 means A bitwise AND means 1. So that is, here you can see 1, 1 means 1. Again 1, 1, 1. 0, 0 is 0. 0, 1 means here you see 0, 1. It is 0. In the same way, A bitwise or A, X or B and not A. Right, not A. Not A means what? 0 will become 1, 1 will become 0. Reverse it will be. So that means it is going to give you negative number. So bitwise operators supported by C++ are listed here. So these are two more extra: binary left shift operator and binary right shift operator. The left operand value is moved left by the number of bits specified by a right operand. A left shift operator by 2 will give you 240. Any values are given for A and B? No. And a right shift operator where the left operand value is moved right by the number of bits specified by digit will give you 15, which is this number. We have something called a shorthand assignment operator. Here, as I said, like when you write A equal to 10, usually we read this in mathematics. So in mathematics, you read A equal to 10, but in programming, we don't read this as A equal to 10. We say value 10 is assigned to variable A. So we have shorthand assignment operator. On the left side, you can see those things: minus assignment, multiplication assignment, division assignment, modulus assignment, plus assignment, like this it is there. If A plus 10 assigned to variable A stands for, see, the shorthand assignment operators have to be used when before the assignment and after the assignment there must be a same variable name. In such case, you write first variable name as it is. After the assignment, what we have, that you skip it and write that plus sign, then assignment, then the value. So both equations are same, but this is little shortcut, right? Similarly, if it is B equal to B minus A, how do you write? B minus assignment A. The same thing applies for remaining operators. It is not mandatory to write like this. If you want, you can use like this. All assignment operators have lower precedence than the conditional operator. So here, the condition precedence in the sense, like in the mathematics, how you will use BODMAS rule, no, to evaluate the equation so that everyone should get same result. In the same way, here in programming language, we have precedence of operators. and associative rules that will come. So based on this precedence and associative rules, the expressions or the equation will be evaluated. So they say that precedence, all assignment operators are having lower precedence than conditional operator. This is question mark colon. It's called as conditional operator. These are all assignment operators only. Along with this, see left shift and right shift and assignment operator. Bitwise and assignment operator is there. For all these things, you can apply that shorthand assignment operator. No, only assignment operators, these are not shorthand. And the special operators, size of. Size of is an operator, even though it is in letters, it is an operator which is going to tell you how many bytes of memory required to store a particular type of value. Suppose if I'm saying size of A, if A is integer, it will return 2, saying that this variable A, which is of type integer, requires 2 bytes of memory. So this is used in complex programs to calculate the memory requirement for a particular array, structure, strings, and all. And we have comma operator, which is used to separate the related expressions using comma sign so that it can be written in a single line. You need not to write it in a separate line. You can club more than one related expressions into a single line. Dot operator and arrow operator is there. Member operators used to reference individual members of a classes structures union that you can see in the classes chapter. So cast operator, casting operators convert one data type to another. Means we don't have a word called as a cast. It is a type conversion. Say, suppose if there is a value 2.3, which is a decimal value. If I want to convert it to integer, we write like this, 2.3. This says that 2.3 will be converted to int. That means you will get only integer part, that is 2, decimal part will be discarded. And we have address operator and pointer operator. We have ternary operator also. Today this much is enough. Today this much is enough. In the next part, we are going to start with ternary operators. Okay. So kindly subscribe our channel. And if you like the video, kindly share our videos with other students so that even other students should get benefited. Thank you. Have a nice day.